welcome back everyone. So in this video, we are going to see how we can test our program in Rust. So in the next project, we are actually going to do front-end testing, but for this project, we are going to use Rust testing so that you will have a clearer understanding of what's going on actually and what is needed for our program to work. In order to save time, I will not write this code with you guys. So I'll have this inside the template so you can also access it at any point of time. And I will just go through over it to see what is actually implemented in here. First of all, it's going to be an async test because it's going to include multiple program invocations and it's going to actually contain creation of the program itself. We need to have some await statements inside, and that's why it's async. We are going to start with the program ID. We are going to set it to a transfer tokens with a lot of ones as a string. And just like the requirements from our accounts vector, we are going to define some key pairs. The source, mint, destination, and authority public key all required for our program to work. After we are done defining this key pairs, we are going to create our program with name of CPI transfer with the program ID that we have just created. And we are going to use process instruction, just like our regular entry point. And then we are going to set amount and decimals. These are going to be used later for the token program to create a token. We can actually start our program. So we are going to use Banks client for this as well. And what I mean by use is we are going to define the outputs of our program starting with Banks client, payer, and recent block hash. After this, we are ready to create our own token. So for that, we are going to use another CPI inside our test case this time. We are going to create an account and we are going to initialize the mint. So for the create account, we are actually going to create a simple account. So it has from, to, Lampert, space, and owner. And the owner is going to be the SPL token itself. After that, we are going to create a token with this initialize mint. It's going to contain the decimal that we have just created. So it's going to have 9 decimals, which means that one token that we are going to see in frontend is going to be equal to 1 multiplied by 10 to the power of 9 in the backend side. Then we are going to process this instructions. After this point, we are going to have the token ready. We have created a SPL account for the token, and then we have initialized the mint. So we have some tokens ready. Then we are going to move on to our second account that we are going to need, which is the source account. So we are going to transfer money from our account, which is we are the source account, to another account. For testing, we need to mock the source account as well, since there is no account inside this test. For that, we are going to use create account and initialize account. So the create account is from system instruction, just like token account. We are going to initialize it so that it's going to be containing our public key and authority and mint. After this is done, we will have our own account. So this is the source account. Other account we need is actually the recipient account, the destination in our program, as we have mentioned it. So the source info, we have this one. Mint info, we have this one also because we have minted tokens. We need this destination info and authority info next. For our account, we are going to define a destination account with create account from system instruction and initialize account from SPL token. After this, we will have actually some accounts we can use with their own PDAs, but we haven't actually minted tokens for any of the accounts. So no one has this token yet. In order to solve this, we are going to use another CPI, which is called mint2. So it's going to mint some tokens for our own destination account. And when I mean my account is actually the destination PDA. So as you remember from our last project, maybe the Solana programs doesn't have a state on their own. So we need an account which is accountable for storing our own token. That was the account we have created. And now we are going to mint some tokens to that account. We are going to give the amount we have defined in here. So we can just change this value and it's going to be working fine. After invoking this mint2 function, we are going to have our own tokens. Then we are going to convert these accounts to account meta with new. And we are just going to give all of the account values we had. And after that is done, we are actually ready to call our actual function. We are going to do that with this process transaction, which is provided with this transaction. So as you can see, these are the accounts that we are looking for inside our process instruction. These 5 of them are matching these. And program ID is what we defined in the first line here. That's our program ID. And for the data, we are not using it, so we can just leave it empty. When you have this, actually, you can just use cargo test, just like last time, to test our application. So it's given a warning saying that this is not used. we can just delete that, no problem, since it's not an error, it's a warning. But as you can see, our program is actually having some print statements. So let's take a look at them to see what we are doing. Just like what we have described in our test cases, we are invoking the initialize account first. So it's going to initialize an account that is accountable for storing our tokens, and it's going to print out success. So we need to be careful about this success or fail statements. But since our test is passing, all of our functions are passing as well. Because if not, it would give us an error. The first one is initializing the mint. The second one is initializing the account. So it's this one. This is the source account, our actual account. And after that, we are going to have the destination account set. So these are all successing. And you can see how much gas fee we need to pay for this whole operation as well, with this consumed this much unit. And it's going to be followed by mint2. So it's the actual function to mint tokens for our account. We are going to call this transfer check, which is our own function actually, which is the function we have implemented in the last video. And after this transfer check, we can see that everything is success, so nothing is giving us an error. We are just unpacking the token account to see if token account that amount is equal to amount, and it's also not yielding any errors. So this means that our destination account holds all of the tokens that we have owned previously. This is how we can make sure that our test is working. And in the next video, we are going to have a relatively more complex application, which is going to have a front end as well.